In this video, we're looking at integrating 1 over x. So from methods, we know that if we integrate 1 over x, we get the natural log of x, and x has to be strictly positive. However, 1 on x is defined for all real numbers, not including 0. So that integral also has to exist for all real numbers, not including 0. So we can't just look at only x bigger than 0, we have to also think about what happens when x is less than 0. So if we consider the function y, which is natural log of the absolute value of x, where x cannot be equal to 0. So y equals natural log of u, where u is the absolute value of x, so u is positive x when x is positive, and negative x when x is negative. So basically it just does a flip. So the derivative of that, well, the derivative of x with respect to x is 1, and the derivative with negative x with respect to x is negative 1. We then have that dy du is equal to 1 over u, since u is greater than 0. And so using chain rule, we see that dy dx equals dy du times du dx. So we get 1 over u times 1. We get 1 over u times negative 1. So we can see that our answer is 1 over absolute value of x, 1 over negative absolute value of x for x less than 0. So up onto the right here, we see we get two negative symbols and those cancel out. So it's just 1 on x for x not equal to 0. So if we integrate 1 on x dx, we actually get the natural log of the absolute value of x, which accommodates for all real numbers except x equal to 0. All right, so let's combine that new idea with the idea that we looked at in the previous episode and compute these two integrals. So we have x take 3 on x squared take 6x plus 13. So if we differentiate the denominator, we get a factor of the numerator. So let's see if we can do some cancellation here. So we let u equal x squared take 6x plus 13. So du dx is equal to 2x take 6. So dx is equal to du on 2 times x take 3. And we can see that x take 3 is the numerator there, so we are going to get some cancellations. Let's continue through with this problem. We have the integral of x take 3 on u times du on 2 times x take 3. So again, I've just replaced dx there with du on 2 times x take 3. And I've replaced x squared take 6x plus 13 with u there. And we get some cancellation between our x take 3 and our x take 3. So this is the same as finding the integral of du on u, which is just the natural log, of 2u, which is just the natural log times a half, because we can take out that factor of integration. And so we're left with 1/2 natural log absolute value of x squared take 6x plus 13 dx. But if we were to look at this quadratic, it is actually strictly positive. So we can test that with the discriminant b squared take 4ac. So that's going to be 36 take 4 times 1 times 13. We can see that's going to be less than 0. So we're not going to have any roots, which means we're either strictly positive or strictly negative, depending on the leading term. The leading term is positive, so this is actually the same as 1/2 natural log of I don't know why I wrote dx here, that should be a plus c, of just the bracket. We don't need the absolute value, because there is no point in which that function is negative. All right, part B, a little bit more complicated. So part B, if I were to look at the denominator, we can see that the derivative of that is going to be 8x take 12. Now 8x take 12 is most certainly not 6x take 5. It's also not a multiple of 6x take 5. So we have to transform that 6x take 5 into something that we can actually work with. So to do that, excuse my ruffling paper. So again, we are going to consider u is equal to 4x squared take 12x plus 9. So our du dx is equal to 8x take 12. We want to now write 6x take 5 in terms of 8x take 12. So write 6x take 5 in terms of 8x take 12. So we get something times 8x take 12 plus another something is going to equal to 6x take 5. So we can see our 6x is going to be equal to 8x times a. So a has to equal 3/4. And if a equals 3/4, we're going to get negative 12 times 3/4 plus c is equal to negative 5. So c has to equal 4. And what this does for us is it breaks up the function into two different integrals. So we get the integral of 3/4, our a term, times 8x take 12 on our u term, 4x squared take 12x plus 9 dx. And we get another integral, which is the integral of 4 on 4x squared take 12x plus 9 dx. And so now, when we do our u substitution, we can get that cancellation of 8x take 12, and our right integral is just a polynomial. It's a polynomial in the denominator, but we still know how to integrate that, just using our methods. So let's actually split this up. So left-hand integral is going to be... well, first of all, we need to know what dx is. So dx is du, scrolling back up here, on 8x take 12. So we're going to get, with our substitution, 3/4 of 1 on u du. So that's just going to give us 3/4 natural log of 4x squared take 12x plus 9 plus c. Okay. Then our right-hand integral, we've got the integral of 4. Let's actually take that out the front. Of 4x to the negative 2. Sorry, that's not technically true. So we've got 1 over. If we were to factorize this, we get 2x take 3 squared. So substituting u equals 2x take 3, or let's use v for this. So v equals 2x take 3. That's the same as asking us to find 4 times the integral of 1 on v squared, and then dv would also have a coefficient of a half, because dv dx down here, dv dx is equal to 2, so dx equals dv on 2. So that's where that a half comes from. So what this gives us is 2 times the integral of 1 on v squared dv. And we don't have to use natural logs here because it's a power greater than 1. So that just gives us minus 1 on v times by 2, so that gives us minus 2 on v plus c. So substituting v back in, that gives us minus 2 on 2x take 3. So our final equation is 3/4 natural log of absolute value of 4x squared take 12x plus 9 take 2 on 2x take 3 plus c. And I'm just going to quickly check that. Give me 2 seconds. Oh, I missed something. So we're almost done here. There's just one step we can do, which is to simplify our natural log. So obviously with our log laws, if we can write it in terms of a square, we can drop the square at the front. So this can be written as natural log of, as we saw before, 2x take 3 squared. So take, that's take 3 plus c. So drop that 2 out the front, we just get 3/2 natural log of 2x take 3 take 2 on 2x take 3 plus c, and that is our most simplified form. So not too much for this video, just looking at this idea of 1 on x, what happens with our natural log, and how we can simplify our integrands so that the quotients cancel out. Thank you very much for watching.